All right, let's take a look at this lesson. We're going to combine both kinds of sequences and series that we've learned. So let's just review just for a little bit on arithmetic sequences and series. Remember, those were the ones who, we can just go back and look at them real quick. Why not? So arithmetic sequences and series, you recall they had a common difference. You added or subtracted the same number over and over again. Okay. Then we talked about geometric sequences and series. Those were the ones where we would multiply by the same number over and over again, or divide by the same number over and over again. Right now, for this lesson, what we're going to do is we're going to pull all that together, and we're going to do word problems of both types, both arithmetic and geometric. Okay, so it would be good if you had your calculator. Let's take a look at the first question. So we've got a well drilling company charges $15 for drilling the first foot of a well, $15.25 for the second, $15.50 for the third. Let's go ahead and let's put down the term numbers. So A1 is 15, A sub 2 is 15.25, A sub 3 is 15.50. Okay, let's see, what kind do we think that is? Well, looks like arithmetic. If we do 15.25 minus 15, we see we get 25 cents. Okay, so good. So our D is going to be 0.25. All right, great. So let's keep reading the problem. How much would it cost to have this company drill a 100-foot well? Okay, we know it's arithmetic. Let's go ahead and write both formulas down. So we have A sub n equals A sub 1 plus n minus 1 times D. Okay, that's our sequence formula. Now let's write down our sum formula. S sub n equals n times 1 A sub 1 plus A sub n over 2. Okay, so let's think about this. So what would happen if we put 100 in here? What would we get if we put 100 in, in D, of course, and A1? If we filled out that formula and put 100 in it, what would we get? We would just get the cost of the 100th foot. That's not what it wanted. It doesn't want to know the cost of the 100th foot. It wants to know how much would it cost. How much would it cost to drill that whole 100-foot well? So that sounds like that's a sum. Okay, so we need to use the sum formula. Let's see what we have so far. We know we want 100 feet. Okay, we have our A sub 1, it's 15. We don't have our A sub n. Let's think about that. So we need to figure out the last term. Okay, so if we want our A sub n, we're going to use our A sub n formula. So we want the 100th term. So our first term is 15 plus 100 minus 1 times our common difference of 25 cents. Now I've gone ahead and put this in my calculator just to make things, go a little faster. And we've been working on our calculator skills for several days. Hopefully you're okay with it. So the 100th term would be $39.75. All right, let's finish this formula over here. So 15 plus $39.75 all divided by 2. Okay, so again, I went ahead and put that in my calculator too, just to kind of speed things up. So the 100th term is 2007, no, not the 100th term, the sum of all the first 100 terms are $2,737.50. Yay, we got our first problem. That's arithmetic. Okay, we just have one more problem, and this is a little tricky. It's a little tricky, so let's kind of read through this. So from 1982 to 1990, the amount in millions of dollars. Why do you think they do that? Why do you think they write in millions of dollars? Okay, that means this formula is written in millions of dollars. And so when you write your answer, you need to write the number and then millions. Just a little bit more convenient than writing all those zeros and such. Okay, so let's see, of guaranteed student loans we made by, so we have this formula. So take a look at it. Take a look at this. What kind of formula do you think that is? Okay, that's a sequence formula for geometric. Let's remind ourselves, what is that spot? That's R. This spot is A sub 1. Okay, so that's our sequence formula. Now, the reason this one is a little confusing is because they are actually starting this problem out at an n of 2. They're saying, so a lot of times when we use years, they will come up with like a representation. Instead of writing in 1982, they're going to write in the number 2. So this formula that you see over here in green was created using 2 for 1982 instead of 1982. Okay, so it's actually the second term. I don't know, maybe they wanted to match the 2, who knows. But what that means is we want the total amount of guaranteed student loans. So we need the big sum figure. So let's write down both formulas. Why not? So a sub n equals a sub 1 times r to the n minus 1, and s sub n equals, let's see, what is that? That is a sub 1 times 1 minus the rate r to the n over 1 minus r. Okay. All right. So that is our 5650.2 is our a sub 1. This is wanting us to start at a sub 2, not a sub 1. That's what's pretty confusing. So we need to find a sub 2. That's what we need to do. We need to find a sub 2. So a sub 2 would be 5650.2 times 1.2 to the 2 minus 1. And again, I put that in my calculator. It's 6,780.24. All right, good. So instead of using a sub 1 here, we're actually going to use a sub 2 because that's where they started. And that's just what they did. So here we go. So we're going to put in 6780.24 times 1 minus, let's see, our r is 1.2. Ooh, we don't have the n. All right, let's go ahead. Now, we're going from 1982 to 1990, and some students want to just say, oh, well, 1990 minus 1982 is 8. But that's not really how many years. So let's just demonstrate by writing the years out. 1982, 1983, 84, 85, 86, 87, 88, 89, and 1990. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. See, there are 9 years here, not 8. And you may already know that from like previous work. I just want to be sure we understand that it's not 1990 minus 1982 equals 8, and it's 8 years. It's actually 1 more than that. Isn't that weird? All right, so that's to the 9th over 1 minus 1.2. So this is actually our S sub 9 formula. We're counting up 9 terms. All right, and again, of course, I put that in my calculator. So we come up with 141,021.55 million. Great. All right. So that should finish up this lesson.